All right, so let's see how we take a rate law, which we can determine experimentally to probe how a mechanism or how a reaction is actually occurring, right, to the mechanism. So let's say some things first. We have to say first that a reaction is the sum of its steps, right? That makes sense. You can't get to the end point without being somewhere in the middle. And then another thing that we have to know in chemistry is that one step of the reaction mechanism is very often much slower than the other steps. And this much slower part is very important. I mean, that it is much, much, much slower. And this is what we call the rate determining step. Right? It's the slowest step that's going to tell you how fast you can get your job done, right? If one person takes 1 second and another person takes 10 years, it's the slow step that really determines how fast your reaction is going. So here's just like an analogy from one of the books. It's kind of like this traffic jam, right? It doesn't really matter how fast you were going before you hit this traffic jam. All that really matters is how slow you or fast you can go during this traffic jam part. But this isn't a perfect analogy because it's not the same factor when it comes to chemistry. When it comes to chemistry, one step is much, much, much slower than the other steps. So it's much more exaggerated.